This week we're going to start our unit on regression, particularly descriptive methods in regression and correlation. Linear regression and correlation are two commonly used methods for examining the relationship between quantitative variables and specifically for making predictions. We can look at how two variables are related to one another and how well one variable can be used to predict another variable. So our outcome variable. To do this, though, we have to kind of review what we learned in algebra about basic linear equations. So you all recall this equation, y equals mx plus b. And do you recall what each variable stands for? So your y and your x are just two variables that are related to each other. M, remember, is slope of a line, and your b is the y-intercept. So, for example, let's look. If we have these 2 points, 3, -5, and 2, 7, we can form an equation of a line that goes between those 2 points. So let's see if we can remember how to come up with that equation between two particular points. To get your equation, you need your slope. Well, if you have 2 points, remember slope is change in y over change in x. You might remember the equation y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So for this particular equation, we would have 7 minus -5 over 2 minus 3. Now, it honestly does not remember it doesn't matter which of these points you start with, but if you're going to subtract 7 minus 5, then you have to be consistent for the x values in the denominator. So since I started with the 7, I need to start with the 2. If I decided to do -5 minus 7, then in the denominator, I would have to do 3 minus 2. Again, you just need that consistency. So 7 minus -5, 7 plus 5 is 12, and of course 2 minus 3 is -1. So our slope is -12. And we can see this in the little sketch that I drew here. -12 means we're going down 12 units on the y and just 1 unit over on the x, because it would be -12 over 1. Or you could use 12 over -1, but I don't have enough space here. We could come to this point, and that means we're going up 12 units for the positive, but then the 1 being negative means 1 to the left. Either one is correct. Now, so far, I have y equals -12x plus b. So the question is, how do I get that y-intercept? Well, we can see from our graph it's going to be a large positive number. To get it, though, I simply have to plug in one of the points that is on the equation, the line. So I'm going to use the 2, 7. The 7 is the y value. The x value is the 2. Go ahead and solve for b. And I get b equals 31. So the equation of this graph would then be y equals -12x plus 31. The graph would cross the y-axis at the y value of 31. And then to get from one point to the next, you would move 12 units down and 1 unit to the right. It's a very quick little recall from algebra. we're going to use this idea of the linear equation. We're going to change the variables a little bit for statistics. Our y equals mx plus b formula that you're familiar with is going to now become y equals b sub o plus b sub 1 x. So there's a couple things I want you to get used to right away before you do any of the work in this unit. Number one, your y-intercept is written first, followed by the slope and x term. Your y-intercept was a b, now you're going to write b sub 0 for your y-intercept. Your slope, which was m, the notation for slope is now going to be b sub 1. And there's a very specific reason for this. In our unit in Stat 2, we are only going to do what's called simple linear regression, meaning we are going to look at how one variable can predict or how it is related to another variable. X is our independent, or what we call our predictor variable. The y is our dependent, or what we call our outcome. So we're looking at how well is x related to y, or how well is one variable x going to predict another variable y, like SAT scores. How well would our, say if our one variable x was SAT scores and y was how well you do in college, your college GPA, we would look at, well, how well does our SAT scores predict our college GPA, or outcome? But in reality, when regression is used, it can be used for multiple variables. So this equation would continue with a b2, x2, and that could be your high school GPA. It could be b3, x3, a whole other of factors, because we know your college success, your college GPA is certainly influenced by more than just your SAT scores or your placement test scores or your high school GPA. There's a lot of factors that could go into predicting how well you do in college. But for us this semester, we are only looking at what's called simple linear regression. So we are only going to look at how one variable predicts another. Real quick review of slope. Positive slopes, anytime your slope, remember slope is b1, anytime your slope is greater than 0, meaning it is positive, that means your equation is rising when you go from left to right. It could be very steep. It could be not too steep at all, but as you move left to right, your equation is rising. That means you have a positive slope. If your equation is decreasing as you move left to right, you have a negative slope. Okay? Now, what if your equation is perfectly horizontal? Let's suppose this is the point 2, 1. And this point over here is negative 3, 1. Notice, if you have a perfectly horizontal line, one thing is always consistent, regardless of what that x value or that predictor or independent variable is. Your dependent variable, your outcome is always the same. It's always going to be 1. This occurs anytime your slope equals 0. All horizontal lines have a slope of 0. And when that occurs, the second term, because your x is 0, goes away. And you simply have y equals b sub 0, which would be your y-intercept. In this particular problem I put up here, it would just be y equals 1. Okay, so this is an example where the x variable, the independent variable, has no relation on the outcome. Because regardless of what number we would plug in for x, you're always going to get a y equal to 1. So let's take a look at one application problem that you could see in your homework for this first section. Here's a model for a rental-car cost. Y equals 68.22 plus 2.25x. This is for a one-day rental where x is the miles driven and y is the total cost. So first of all, if you're looking at this, can you identify the b sub o and tell me what it represents? So in this particular problem, remember, b sub o is your constant. So again, in this first section, you're getting used to the new notation. B sub o is that constant. It's always going to be written first. So b sub o $68.22. Now, what does it represent? Well, let's suppose this second term just went away and there were no miles driven. If there's no miles driven, you're still going to pay $68.22. So this represents just the cost of renting the car, regardless of the number of miles you drive. So the second you rent that car, you're automatically charged $68.22. Now, b sub 1. Which of those is b sub 1? We now recognize b sub 1 is our slope, which means it's our coefficient of our x. B sub 1 is 0.25, or 25 cents, times however many miles driven. So it's the cost per mile. You were going to pay 25 cents per mile driven. Okay. So every mile you drive, another 25 cents is added on to your total cost. So let's suppose we drove 100 miles. We want to know what the cost is. X is the total miles driven. Y is the cost. So we would plug in 100 for X. .25 times 100 is, of course, 25. Add that to the $68.22, and you get $93.22. So if we drive 100 miles, then our total cost is $93.22. So again, this first section is just to give you a brief review of basic linear equations.